Good morning, this is Roger and my fellow groupmates. Today we will be doing our ICT200 presentation titled Malindo Inventory Management System. For our group members, we have me, myself, Isaac Noel Oliver, Muhammad Nasmi bin Muhammad Noor, Muhammad Daniel Hidayat bin Sarudin, and Awang Haikal bin Hasmadi. For our company's background, Restaurant di Malindo is a local Sabahan restaurant established in 2014, serving authentic Malaysian cuisines and homestyle dishes by dedicated business owners Muhammad Noor ibn Ibrahim and Rimalini binti Ismail. Located in a bustling area, the restaurant has become known for its warm and welcoming atmosphere, serving only the rich culinary heritage of Malaysia. The restaurant has been running for more than 10 years and has built a loyal customer base, focusing on providing delicious food with the highest quality ingredients. Despite its success, the restaurant currently relies on a manual system for managing orders, pricing, and inventory, which has led to challenges such as delays in processing orders, difficulty in inventory tracking, and maintaining consistent service quality. For the vision, their vision is to become the preferred choice for Malaysian cuisine, offering exceptional foods and services while embracing modern technology to improve restaurant operations. Their mission is to serve authentic Malaysian and homestyle dishes with care and dedication, ensuring customer satisfaction through consistent food quality, excellent service, and efficient operating system. Their objectives are: the first one is to make the order management process faster and more accurate, and the second objective is to implement a database system for real-time inventory tracking and menu updates, and the third objective is to reduce errors and delays made by manual processes.
So this is the organizational chart of the company. For the next one, I will explain our current system description. Restaurant di Malindo currently uses a manual system to manage its order, pricing, and inventory. This system relies heavily on handwritten records, which can lead to delays in processing, errors in calculation, and difficulty in maintaining accurate record of orders and stock level. As such, the current system disorganized, making it difficult for staff to share information efficiently and for the restaurant to monitor its performance in real time. The flowchart below shows the current system flow. This is our current system description for the flowchart. So this is our problem statement. First, frequent errors in order taking and calculation due to human intervention. This happened due to staff misinterpreting customer orders or making mistake when taking orders. Additionally, manual calculation for pricing and totals can be affected by tiredness or distraction, leading to inaccuracy. Next, difficulty in updating menu prices promptly. In a manual system, updating menu prices requires a manual labor, often across multiple locations, such as physical menu or the system and price list. This leads to delays and errors, especially if the restaurant needs to adjust price quickly due to market change, special promotion, or new supplier costs. Last but not least, inefficient inventory tracking leading to stock errors. Without a real-time automated system, tracking inventory manual becomes time-consuming and error-prone. Staff may forget to update stock level after sales or misplace them, leading to errors in the actual stock against what is recorded. This can result in overreading or running out of ingredients, affecting service and customer satisfaction. And for the next one, our database objective. First, to identify the requirements for inventory management and storing. Next, to design a database for inventory management and storing. Last but not least, to develop a database for inventory management and storing.
The next part is business rules. The purpose of business rules is to ensure data integrity so it can prevent invalid or inconsistent data, and it also maintains consistency. Let's take an example here. For the first one, a customer can place many orders, but each order is associated with only one customer. This business rule describes a one-to-many relationship between customer and food orders, where a customer can have many orders, but each order only belongs to one specific customer. Next, our ERD. We have the entities, attributes, relationships, primary key, and foreign key. This is to model the data, relationships, and structure. The relationships that we use here are one-to-one, one-to-many, and many-to-many. Next is our 3NF relational schema. So in this part, we have 3 pairs, which is 1NF, 2NF, and finally 3NF. In 1NF, we eliminate repeating groups, identify primary key, and identify dependencies. In 2NF, we eliminate the partial dependencies, reassign corresponding dependent attributes, and finally, 3NF. We eliminate the transitive dependencies and also reassign corresponding dependent attributes. And finally, this is our data dictionary where it's contain metadata, which is data about data for database. The purpose of it is to ensure that everyone using the database understands the structure and format the data. Now I will let my friend to present the next slide.
Now, I will show you the database implementation for each table, which uses SQL language. For each table, we enter at least one primary key and optionally foreign key if there is any. Each table is complete with its attributes that we have shown you in our ERD or data dictionary. So this is the database implementation for table owner, co-owner, customer, staff, menu item, ingredient, inventory, food order details, and payment. Now, we will show you the 6 SQL questions that we have done to prove that our database works as intended. Question 1. Show the total revenue generated from all food orders. This is the SQL command to show the total revenue generated from all food orders. And this is the output. Question 2. Find the most expensive menu item. This is the SQL command, and that is the output, which shows that menu item ayam masak lemak cili padi has the highest price of 12 ringgit. Question 3. Show the total amount of payments made for each payment type. This is the SQL command for the question, and this is the output. Question 4. Find the total number of orders handled by each staff member. This is the SQL command of the question, and this is the output. This shows the total number of orders handled by each staff member. Question 5. Show menu items that cost more than the average price of all menu items. This is the SQL command, and this is the output. What this does is it counts the average of all the prices, and if it's more than the average, it will output and it will display whichever has higher than the average price. For question 6, show customers that have ordered menu for nasi lemak and nasi biryani. This is the SQL command for the question. And this is the output. This shows that customer Hazik Lukman bin Idris and Amirul Hazik bin Rahman has ordered nasi biryani and nasi lemak. To conclude, the database project for Malindo inventory system is expected to improve for inventory management and storing. It supports to make the list become more polished and ensuring the list remain clear and easily accessible, so the burden will be minimized for the company when searching for specific items, reducing errors and improving overall efficiency. That is all from us. Thank you so much for your attention.